So today's discussion session is related to STEP, APs, and components of STEP. There's quite a few topics I could have chosen, but I went with the following context. So first, I wanted to discuss collaboration types. So as some of you may know, or as maybe you've studied before, is that collaboration can take many forms. So first of all, like we can have many people working on the same task, and then the same people work on the next task, and then the same people work on the next task. This is like one form of collaboration. But this can be very like resource, intensive. So maybe we don't need 3 people for the first task. Maybe only one person can do this, and then one person here, and one person there, and they just hand off from each other. So the output file from this guy should be shared or accessed by this software, and then the output from this software should be shared or accessed by this software. Another form of collaboration is the parallel collaboration. So like the mechanical guy can do some design, the electrical guy can do some design, and the software guy can do some design, and then they validate the design or combine it together in one activity. So, with all of this in mind, with these types of collaboration in mind, we can discuss about the importance of sharing and exchange. So what is the role of sharing or exchange in collaborative engineering? What do you think? To make an efficient design or analysis or even documentation of a very complex airplane or ship, you will find many of these types of collaboration inside a company, inside one department, or even inside a team. You can find many of these types. So what do you think is the role of file sharing or exchange or STEP APs to facilitate collaboration? If you have anything to add on this slide before we move on, please do. Why do we need sharing? Why do we need standard? How can it help in collaboration? Why can't you just have the file formats themselves? Whatever CAD software file format, whatever finite element. I know this is repeated, but if you have anything to say, please do. The importance of file sharing and exchange. Why do we need to exchange files? Okay, let me kind of change the question a little bit. So, with all of that in mind, with the file sharing and exchange, with the collaboration in mind, let me introduce the concept of open source development. I'm sure some of you already know this. So this is a if you want to think about it, like even in this form of development, we have this guy developing a small part, this guy developing a small part, and this one developing a small part of one software, and then they're being merged together. So, and it's done through the internet. So anyone in the world can be part of the team. Anyone in the world can take a copy of the software, improve a part of it, and then merge it into another copy. So obviously with the approval of the original person. But that's the idea. So we have this form of extreme parallel collaboration. So to achieve this, what do you think is missing? Do we need can we do something like this in product development? Is there a possibility that maybe we can have a car design and then everyone in the world can go in and try to modify the car design or try to add some parts? So mechanical engineers will do mechanical work, electrical engineers will do electrical work, artists will draw different cars and so on. What do you think is the obstacle to going to this step in product design?
What is AP here? Application protocol?
Right.
Are there free APs?
Excuse me?
Are there free APs available?
No, it's a question. It's like a debate question, but I'm coming to it.
So if there are free APs.
Right. Should there be some free APs, or should it remain as commercial? But first, let's talk about the obstacles to collaborative development of products. Why collaborate? Why form of collaboration? All the world can collaborate into designing something. What do you think is the
Each system has their own character, and for example, the electrical cab and the mechanical cab is, and the ship and plant cab is the different. And so, as you say, the integrated like CAD system, it has to contain the whole characters, the electrical or the plant CAD system. So the size becomes so huge. So we cannot make all, we cannot use it.
cannot use what?
Cannot use the system, the integrated system.
Right.
Because the size is so huge, and there is the userless functions in there. So separated system and just exchange the data is helpful, but the integrated system is not useful.
But maybe, like, what do you mean by integrated system?
You said we can modify the models, and every people can modify.
Right.
So that means one model has the engine or the electric lines. So for designing the electrical lines, we need electrical system, and for designing the engine, we need mechanical system. So the system contains the whole CAD systems.
Right.
I mean,
but the CAD system itself is just an input-output device. Like we can have a product file as a step file, for example. It's a very comprehensive file, but then one CAD system can read part of this file, and then the engineer can modify parts of it, and then it updates the original file. And then electrical CAD system can read another part of the file, and then the engineer can interact with the system, and then it will save the result in the comprehensive file. So the file can be more like a database. You know, the design file can be a database combining all the semantics basically of the design. So the way I view a CAD system is just as an interface. You know, it's just a way to read part of the file and then modify it. So maybe it's doable, maybe not. You just need to have the proper interfacing, like how to read the relevant parts of the step file and not all the parts of the step file. Anyway, so okay, so we can have a debate question. Apparently, this is the only thing that gets you excited. So we will have two teams, and one team should argue for having free APs or standards. So STEP should just make all its APs available to everyone for free and online search. And the other one is to argue for commercial APs. That APs, it's a product, there's a lot of effort that went into it, and we have to sell it for money to make some money. So you choose. Okay, so the TA and Wang are one team, which makes the other team choose the top. Like you choose the side you want to be on, because the TA is big. It's too big.
So I pick one.
What?
Maybe
they take one. They take one.
Yeah, they take one.
You choose one.
And after some hour, you can change the position.
Sure, this time. Which one do you want? AP standards.
Yes.
So, yeah, go on.
Who makes free AP standard? Who makes?
No, we're arguing if they should be making it free or if it should remain commercial. I mean, some APs I think are free, but as far as I've read and I found, step APs are not. It's you have to pay for it.
Or international standard is not free.
It's not free? Yeah.
You should buy from ISO or
Right.
RC.
Right.
But during process, the unfinished ones can be open.
Right.
The final version is should be purchased.
Who wants to start?
Well, I can say that the price is very low compared to the cost
Right.
of developing standard. So you can say the current situation is almost free.
But you
Not,
still,
not free, but very small money.
but if it's free, then it's open to everyone to search it and surf it. Like, there's no limitations. Even if it's a small amount of money, you still have to choose and pay before you get that product. But if it's free, you first see the product and then you use it if you want it or not. So, yeah, there's still one obstacle, which is accessibility. How much accessibility do we have before actually paying anything?
And maybe small amount of money may prevent some people to access to the standard or use the standard. But as Professor said, and as I know, almost standards are not that expensive and almost free.
Right.
It's maybe if the reason they get money from the standard is to maintain the organization itself, I think, or maybe maintain this homepage or maintain this organization itself. So I say maybe it's for free, but if it's totally free, maybe more people can get access to the standard and many people can see the standard itself.
Right.
But as the nature of standard is, if nobody is using it, then it will be just disappear. So I think free will be more better. Free or commercial, it's not the issue. If you want to use it, and you should use it, then there will be no obstacle if it's $0 or $200. You just buy it and use it and make some tool.
But you're saying if it's completely free, more people can access it.
Yeah, that's quite right.
Right. Okay. That's one point.
Because I'll take some example. I'm curious about some Industry 4.0 standard. For example, right now I want to see some document, but it's not free. It costs maybe over $100. Then you will give up, and you will find another document that is on the web. So that's the thing that I'm saying right now.
What do you guys think?
someone's effort should be rewarded by money. I think. So, I think commercially should buy or make you pay money.
Right. So you're saying the money is like a proof of policy or something?
Yeah.
It's something worth
Because
buying.
customers select price is the competition.
Right. So when standards are competing, you're saying that price can help with the competition, and like they can try to be better than each other. Okay. But if it's all free, then no one cares really, right? Because it's all free, so no one benefits from like personal benefit. It's all just kind of social benefit or like benefit for the community in general. Okay, interesting.
So the thing is quality, not the price of the standard. So if you find 3 standards which is available on the web, and then you need to pay some cost for the standard, then what will you choose? Cheapest one or expensive one? That actually I think doesn't matter in this context. Since it's costly, so you will buy it. Maybe if it's too costly, maybe $1 million. What's your choice?
I think the commercial, they take money and they should do some extra service like that. And so I think the feedback from the users is faster than free APs and standard.
So if they are providing some kind of feedback system from the standard organization, maybe if I have a question, then ask them, and they can provide us some proper answers, then they can get money from the standard. But maybe at this moment, no standard organization provide that kind of service right now. So.
Do you agree with them?
Actually, I don't know about the word about the commercial APs. So.
That's okay. Okay, so let's move on to the last question, which is how can small businesses and startups benefit from international standards? Just like the TA was saying, he wants to see some standard because he was curious, but it's too expensive, so he doesn't bother. Let's say he wants to make a startup with a field or in a field related to the standard, like Industry 4.0. So you need to see the standard, but then all of these costs, like if your product has some Industry 4.0 components, some ship components, some other components, then there's so many standards that you need to buy, and all of these kind of adds to the cost. And do you think who is benefiting more now from standards? Is it the big companies or the small companies and the startups? And how can small businesses and startups benefit more from these international standards? As you know, most of the employment in a country is by the small and medium enterprises, not necessarily the big companies. So how can they benefit more from these standards so that they can venture into the market? What's your ideas on this? Only too silent today.
Hungry?
Please say something to end.
I think big companies will benefit more from this kind of standard. Like, especially, for example, like in just like the iPhone that we mentioned before, like Apple company, they are quite big. So, okay, so sometimes because they are very big companies, so they have a lot of like even expenditure, like even a lot of stuff. So and even for their products, they have their own standard. So even some small companies can like borrow standard from them and even like follow them, so they can benefit more from those. Like this large company, instead of directly going to the international standard, and also like for those startups, maybe they can follow those small companies because they don't have enough like foundation and fund or even like a lot of human resource, and so.
So you're saying big businesses benefit more from standards, or they ignore standards? I didn't get your point.
They can't ignore standards, but like for big companies, sure they can like follow the international standard because they have a lot of money and even they can even make their own standard. But for the small companies and even those startups, because they are quite like short of money and even like they are like expense, so they have to focus on the most important things. So sometimes maybe they can follow those big companies, and for, because those big companies can help them and with a lower expense compared with directly going to the international standard.
I see. So you say that for small businesses it's harder to go directly to international standards because they lack the experience, they don't know which standard is relevant, or
Yes.
even the money to buy all these standards in the next. So they just follow, like they try to copy the big standard, the big companies' work basically, and then maybe modify it to make a new idea.
Maybe.
Okay, interesting. But that kind of creates a dependence that any new startup has to be similar to a big company's product, or they cannot succeed. They have a low chance of success because you cannot just create something and it's completely different from everything in the market. Like it's not going to work. So you need to have an idea how to plug in your device into the rest of the world, basically. Anyways, this is too long to discuss. So thank you for the fruitful discussion. And if you have any questions,
I'll go faster because like number of students. Okay. But this very historical reason how we develop how the AP, especially AP and structural step is formalized from the beginning. So if you have interested in, then you can go in more details. I divided into sections into two divisions. So is at the beginning PDS. PDS is step center of the United States. That was a very key work. And the idea of IPIN and then CDINS and then go on to other GPDM. Those very similar but a little bit different ideas are coming and emerged during the history. And then there has been also integration task group and application protocol coming in the later stage, and planning model, and also generic part is separated out, and then the technical experts and countdown. So initial release was formalized in about 10 years later. That is the first set of standard, and then after initial release there has been more activity. So domination by US was the early stage with PDS. PDS is United States, the step center of the United States. And subcommittee 4 has emphasis in developing STEP and also product data exchange standard, PDE standard. So STEP is not only focused on what data, but how the meaning of the data. We call this is semantics. And then how to the relationship between data. They also handle these things. at the beginning, it was first time meeting in how many years ago? 32 years ago in NIST. NIST is a United States National Institute for Standard and Technology. It was the first meeting. And second meeting is held in Japan, Tokyo, at the same year. At the beginning, they have a very frequent meetings, four times per year. And nowadays, it is only 2 times. Resolutions is in ISO. They have very formal way to arrive at some consensus, and they publish the consensus as a resolution. So at the first meeting, they has a consensus on mission, goal, and objective. And PDS, the United States Center for STEP, they form a scratch rather than enhancing IGS. IGS was a national standard at that time, very popular. Yes, it's still being used. For developing new standard, they try to enhance IGS, but they decide to abandon them. Okay? So they started new. And Mr. Brad Smith, coming from NIST, was the first chairman until October 1995. So how many years? 11 years. Okay. Myself, I started attending SSO meeting that day, that meeting, October 1995. Myself. So at that time, there is a handover between old chair and new chair. New chair coming from General Motors at the time. So from NIST to General Motors. Resolution 1 in NIST, they recognize the need of the new standard. And existing standard was IGS, and French also have a very similar on set, and German also have a very similar to IGS, was VDA, and also UK has a method. So they all trying to harmonize or improve them, but they decide to abandon the existing ones. This is another way of showing the structure of step standard. So they have different shapes, but description method for express language, implementation method for physical file, and SDI. SDI is something like API, right? Direct access interface to the database, and conformance testing. There is an infrastructure thing. And the real information model comes with operating protocol and some resource model. Resource model is made of 100 series and 40 series. Among them is 42 is very important because of geometry and topology. These figures becoming into change in this famous step on a page slide. We already see several times. And PDS, once again, the step center of the United States. They were initiation effort by architectural things and what is the need for modeling, what is available. So there is a proof of concept project started, and ad hoc group of within the IGS organization. So already there is IGS was popular at the time, 1984. So they have an organization there, but they have a different discussion. At the beginning, so it's very similar. Not AP was not appeared yet, but they already had a similar discipline or domain models, or industry models already there. And then resources are still there. So logical layers, resource and domain or industry model has been already separated off. That idea comes from IGS. IGS has an AP concept at the time. And modeling, what is needed, what is available. 2 things about modeling. We can think about digital twin. I explained about that time. First one is a model is idealization of the real world. not the same, not the phenomenon itself. So real world and modeling, digital world is not different. It is not same, right? So we can speak about digital twin, two things, real world and digital world. Second thing, usually model is a simplification. It's a subset of the real world. And but in here, the digital twin concept, they are trying to make almost the same digital model. In the old days, modeling is a simplification. So beam theory, FEM, CFD, they are all simplification of Navier-Stokes equation or partial differential equation. Right? Real physics is simplified, reduced, because we cannot solve the exact solution. But nowadays, digital twin is trying to make almost same, not the same, but almost trying to almost same digital twin. And it is the languages they used for three different solutions. So the problem of the formal representation of information account, NIAM, IDF, Express was the language. Nowadays, because these are old languages, we are moving for the UML and XML languages. Right? So it comes with the integrated product information model, IPIM. There's architecture. Also, there at that time, US activities was very powerful and big. And now the formal description language of IPM was what? So they develop a new languages. And it comes with the money. Who is supporting that money for the project? Because it is very expensive to develop a standard. You know that I am developing on one ISO standard, Part 57. Right? But it costs big money for me. Not only for traveling money, twice to international flight, right? But my salary, my time. So it is very expensive to develop one single part. So who is funding that project? And so it comes with the display models, IPM, and resource model. There is a separation, but it comes with another ad hoc model concept. And also ES activities, PDS, the organization. It looks like a corporation, something like a company, but it is a non-profit organization for standard inside the United States. Had a very multi-factor step during the formative years in early days. So the homepage is still active there. And formal description language, the expressors of this appeared. And then the information model can be modified, upgraded, and developed. So at the same year, but there's a second meeting in Tokyo, and they have some documentations. You see that this is what passage 4 end of there's a numbering system of documentation. And there you see that working group 1 and working group, these are all working group 1. So that there maybe at the beginning year they have only working group 1. And physical file and express language and scope and definition of part 1 of the step, and test method is part 13 and IPIM was as a formal documentation. And it comes as a context. Context means a domain or industry. Right? Context-driven integration. So it comes of a testbed, national PDS testbed project at NIST, and through PDS initiation effort, and CDIM evolved into first two APs. One of the most famous AP 203. It is still most popular AP all of the steps. So at that time, it is developed by this project. So CDIN is once again has emerged into one more layer. So IPIN is display model, resource model. So you can see the 3 layers already, right? And CDIN becomes into AP stage. So it comes with a concept of application protocol comes in documenting, but not 84. 4 years later, there's another documenting. They started to using concept of application protocol, and that idea is coming from another organization. You see, this is a JTC1. It is not SH4 organization. Another organization. They already use the concept of application profile, and also IGS also use application profile. So in 1990, they has a consensus and produced the formal documentation of Regulation 54 about application. And then application protocol is made of ARM, right? Application resource requirement model, and then mapping table, interpreted model. Those 2 are AP concept, and then resources are and generic model is coming because of this part. This part becomes to general resources, generic models. So they have a new idea of generic protected models as a resources. GPDN and also consensus on formal description language of express. This is very similar to linguistics. Linguistics is for languages, right? Korean, Egyptian, or French, Russian, Japanese. Linguistics also have 2 layers, surface structure and deep structure, and meaning, the semantics and syntactics and semantics is divided. They coming from these ideas so that the AP structure and then generic sources. The GPDM is coming with integrated resources or general common resources nowadays. So coming ideas are coming. And then formal description language under working group 1. But now working group 1 is disappeared. Nowadays working group 11 is working on this language. And then they have a subgroup of 5 and subgroup 6. Bottom up and top down architecture is growing into developing languages for Express. And the languages used for activity model of AP, they use IDF. And IDF has 0 and 1 and 2 and 1x. So there are some subcategories, but usually they use IDF 0 for activity models. And then application object and assertions they use just natural English language. And the ARM requirement model is written by IDF 1x or IDF 0 and 1x, or Express G. G is a graphic, Express G. And then AIM interpreted model is usually written in Express programming. And mapping table has a special, but there's a table format, and generic resources usually written by Express. Alright? Question? No question, then we will move on to second slide. So same part. So in the later stage, but this a little bit more like say the 3.0 is coming. Say that user leveraged influence. So defense, Department of Defense, it's a big organization. Navy, Air Force, US Army. So they need to have a standard to exchange. Because of the cars problem, I mentioned several times about cars, logistics support. Logistics support. Computer logistics support. This is a big program in US Army, Department of Defense. So they want to have a standard. One of them, KAIST standard. One of them is a step. There are many. One of them are steps. Step is very important for step KAIST. And complainers and grippers, they are discussion groups. They are debating each other. Which one is better? Always they debate. Special group on levels. Testbed project. Testbed means implementation. So they are implementation and standard development is coming together. So testing, evaluation, implementation, and also standard development. And test group. And initiative. So it's an organization, step center within form of company. And another organization called plant step. And so plant industry, they have another organization called plant step. And PD information activities. Right. So usual levels defense, Department of Defense. They have a modeling language, modeling method, and supporting architecture. And user, this is very important. Users have a power and money, so they are funding the Department of Defense. They need standard because of the KAIST program. So they are funding the STEP organization or NIST or PDS to develop standard. They are sponsoring. They provide requirement because the requirement coming from Disney, right? They develop standard requirement and also provide money to develop those standards. And another one is Navy. So it's a bit some part of Department of Defense, right? You know that United States, the Department of Defense, the biggest organization is Navy rather than Army or Air Force. Navy is the biggest one. So they have more money. Right? So Navy as a committee was cost sharing, funding, and then private firms and government organizations, ship structures and other things developed. So it comes as a KAIST program. Nowadays they usually call this an e-business rather than KAIST. But at the beginning, they have several names. They started from logistics or military, but they changed it to life cycle support and acquisition, and then e-commerce is coming. Well, nowadays e-businesses. And it is sometimes e-manufacturing comes together, and then NATO is involved in that because it's a defense industry requirement. NATO is also protected there. And special group on BDS levels, 4 implementation levels. Implementation. How do we implement standard? Physical file, or database. And in the middle there is more levels. Active file, and then in future it can be a non-JS. But you can think about exchange of files and database share. That is the most dominant 2 forms. There can be more ideas. Now the AP242, I explained this one in separate lecture, and this is a new one. Right? New one. It's under development. They are combining 2 big standards, AP203 and 203. So AP242 is made of AP203 and AP214. And 203 is aerospace industry, 214 is automotive industry, and it is coming mainly from Germany, and this is mainly from US. So now it's all together into a big standard. So that you can see most of engineering domains are coming in here: PDM, machining, drafting, data quality, shape, composite material, kinematics, assembly, manufacturing information, and process planning. Anything. PDS testbed, they hosted by NIST, but funding sponsor coming from US CAST program of Defense Department. And established in 1988 working until 96, so about 6, 8, and 9 years they worked. And specification. Specification means a standard document. And validation, testing, and tool, software, implementation, they developed it. And plant set. Separate out in 1994, process chemical or electrical power or engineering and construction industry, they have a separate out, and inside NIST and construction industry, they are developing a plant step standard. One of them is famous AP227 about piping plant piping system. And focus on PDE, product data exchange. There is a national initiative for product data exchange. And then, see, IGS is already popular at the time, but it's an old technology. PDS is a step center of the United States. They both are separate organizations inside the United States, but they sometimes collaborate, they sometimes compete, and then they make a new single organization or umbrella organization called IPO. And US Pro Association is more government-oriented organization. It is a private organization. And NIST is a national standard institute. Right? So there is some project facility there. So organization of IPO. IGS working committee was established earlier than 84. But separate but similar standard under two projects, IGS and PDS. This is STEP, this is IGS. But they now make a single or collaborative umbrella organization. And NIST was the key member at the time. So this is chairing the IPO organization. And US Pro is a more government official organization, and name is Product Data Association, but providing management function for IPO, official management system. And then initial is coming in already, and then they have a tiger team to complete one. So they arrive at, this is an organizational chart already, you see that. SH4 is under TC1A4. And at that time there is a working group of 4 and task groups. So because all the industrial domain specific APs are developed on this working group 3. So working group 3 was very big in the beginning. Nowadays it's small. Not small, only oil and gas industry is remaining there. So in 1990, it was first release of a standard. First release. Part 1, express language, pitch profile, conformance testing, and then shape, boundary presentation or topology, presentation, VR something, and directing, and AP for directing. 203 was coming to next year. An idea of AP and also resources divided into application or generate. And then more development, right? More development. After initial release, they have a AP development, architecture, interpretation. Because interpretation was hard, the bottleneck in AP development, how can you improve that? So they have a reorganization of after that. Two major issues was one is architecture, and how can we exchange or sharing? We have a discussion on this, and then interpretation was about here. So how can we improve that thing? And it comes with the ideas of activity model, ARM model, AIM model, and epic table and conformance classes. Already see it several times. And framework. It comes up with several framework for whole SH4 standard. Many people develop different ideas of framework of whole standard. Step on the page is something like a framework, right? But there is another name, industrial framework, integration, modular architecture. Nowadays, modular architecture is prevailing, but there is also coming with a new model-driven architecture coming from OMG. So structural fluid dynamics. This is, for example, the new AP. It is not developed yet. But this is the idea. Fluid dynamics data, and then CFD models, and then resources are used. Right? Resources. This is existing resources. You should have a new part. This yellow one is a new part. The gray ones is already existing ones. So you can combine these ideas to develop a new AP, for example. So there is the idea of AP development structure. And interpretation bottleneck, how can we improve that? So at that time, there are only, it is maybe exaggeration, but only 6 people can do it at that time. What is the importance of integration? APs outside a particular industrial domain, and cost, time and cost to develop AP. So how can you do that? One idea was implementable AP. Did I explain this one before? Implementable AP. Yes or no? Did I explain this idea before?
Implementable ARM.
ARM. They want, because implementation bottleneck is coming from between ARM and AIM, right? This is a mapping table, right? Implementation bottleneck is coming in. So it is very hard to convert this. So that this is made by domain expert. This is a general expertise. No, everybody can understand this. This is domain expert can understand. So they want to make a software direct from the ARM. Because domain expert can do that. So there's a big debate on this. But now they disagree with this idea. So it was one. Redefining AP203 is modular architecture. Okay. So then arrive at new ideas. So, consensus here was not easy. So never happening is debating is always coming. And industry driving because they need a standard. Many industries coming, including this. And also companies. Lockheed Martin, Boeing, these are big companies in the United States on aerospace. Also McDonald's too, right? General Motors was a chair coming from General Motors, the second chair, right? After Brad Smith. Aerospace, and also step automotive. So General Motors and automotive, and also shipbuilding was another big area, right? So this is coming.
Okay, so discussion now. So today's first topic is, as Professor mentioned before, the extended enterprise is a structure where a number of organizations come together and in a joint endeavor in order to achieve outcomes that them could not achieve on their own. So the first question I just derived from the midterm, 2014. So it's got an idea, and so why do those extended enterprises require more standard in terms of information and resources? traditional enterprises who always emphasize on less outsourcing. So like we can see from this picture here, like for the extended enterprise, normally they require a lot for the collaboration, and so but in this process, a lot of problems happen in this process. So the most serious one is like about risk management. So let's first start from question one. Okay. So why do sometimes extended enterprise says require more standards than the traditional enterprises?
Since the question says that traditional enterprise is stressing on less outsourcing.
Yeah, less outsourcing.
So
but the extended enterprise they require outsourcing.
Yeah, more outsourcing.
Yeah, more outsourcing.
Yeah.
So they need like more standards. So they need more standards.
That's your answer.
Yeah. So now we're gonna discuss this question. So why do they need more standards? And so what will be the problem if they need more standards?
I think more outsourcing means more collaboration between enterprises.
Yes.
So in that regard, more information exchange will occur. So yeah, that's my point. So using international standard will give them benefit in terms of information exchange.
Okay. What else? What do you think?
More enterprises means there are more parts or more work. So because of many parts and a lot of work, they need to exchange data in each other. So yeah, they need more standards.
Okay.
What you mean on this outsourcing?
Because in
Traditional enterprise
yeah.
is outsourcing.
Yeah, they can do anything inside their company, so they don't need to focus on the outsourcing. Yeah.
Traditional enterprises don't need to outsource deeper increase of labor cost, but as country's economy go company and one country goes to developed country and labor costs increase, and companies find how can they reduce labor costs, so they outsource their manufacturing, so they have to find how to exchange data. Therefore, standard is more important. Become more important. That
I think. So what do you think about Mohamed?
About what? Sorry?
About traditional enterprises and the extended enterprises, because they focus on the outsourcing, so they need more standards. So how do you think about key?
Well, I think it's expected. Like, if we're in the same company, we can coordinate our choices. We can choose the same software to help make it compatible. So, like, we can, like, let's say we're doing simple fluid dynamics, then we can just use SolidWorks because it has an add-on like this. And the design department is using the same, like, SolidWorks, so it's easier to kind of do the pipeline. But if someone else is doing the simulation, someone else is doing design, and someone else is doing visualization, then it's like different organizations, it's hard to coordinate the choices. Everyone uses the one they're most comfortable with. You need some standard to communicate between them, basically.
Okay. Yeah, but like for example, for the Nike, the company, so all of the resources like are outsourcing. So, but in this process, so it means that they need to focus more on the standards.
Right, but I think there's two types of outsourcing. One is like where the brand has too much power, so they can enforce you have to use this software, you have to use this. Another one is just like collaboration based. So you cannot control what the other company uses, but you still have to work with them. So I think the Nike case is more like Nike is like has the upper hand, and they just enforce any rules they want on the smaller companies. So maybe standard is less important with the case of Nike in terms of like the software standard, because they can like try to make it as if it's one organization. They can try to make everyone use almost the same software. Still, there is a need for standard, but not as much as if you have different companies working. I think for collaborative companies.
I agree with him. Maybe collaboration between the same level companies will require some standard like step.
Yes.
So if you're Nike, then you can force the outsourcing companies to use this one, and they are actually ready to do it whatever you force them to do. So it's kind of different situation, and I point out a little bit different thing is inside the extended enterprise, you will need a lot of systems, and not the whole one system, but many systems connected or disconnected. So if they are not connected well, and you will end up have making a lot of can I say cost. Yeah, cost-wise it will be very inefficient. So inside the enterprise, if they are dealing with a lot of multidisciplinary things, maybe for example a car, we will need a mechanical system, electrical system, etc. So in that case, they might need to use some standard between the system or between the teams, not between outsourcing company and.
Okay. So inside actually in this process of in this process, like so many extended enterprises, they experience the very serious problem about risk. A lot of risks happened before, so now like they are stressing on risk management. So how do you think about this risk management process? Like what do they exactly involve in this process?
Do they? What do you mean by they?
Do they involve in this process? Like,
Who is
what
they?
they want to, like, those extended enterprises?
Enterprise.
How can they manage those risks?
The main thing is expecting well.
Yeah, because we have a lot of collaborations, so.
Yeah. So you need to identify from which point risk might
Just like
may
standards,
or may not be occurred.
like standards. Because there are so many standards, and like we have different tires, and the first tire and the second tire and third tire, and maybe sometimes in the same some companies they are in the same level, and maybe because of those risks, and some companies just like steal something. Yeah.
Still,
Yeah, maybe like they plagiarize.
that kind of risk.
Yeah, and also
Stealing
like
something from the top tier.
yeah, maybe like in this process.
I don't know.
Did you think about it?
Standardizing process, product process, and facilities. So the manager can manage each enterprises easily, because he know he knows the process, and each enterprises use the same process or same parts. So if there is some malfunction or error in some enterprise, so the manager can catch the error easily.
Okay. And how is it?
Okay. One example is, say, Boeing is buying engine from GE, General Electric. General Electric is bigger or Boeing is bigger? Anyway, so Boeing cannot force GE to use some software. Right? Similarly, Siemens is producing some parts for automotive, Volkswagen or Benz. But Siemens is very big, right? So that Volkswagen or Benz cannot force them, Siemens, to use special software. So they are more like a similar size power. So they must collaborate. Otherwise they cannot.